Again, in this video, we are going to be talking about what to do when we have two absolute values that are equal to each other. How do we solve this? Well, as we know, when we solve absolute value equations, we have to consider two solutions. We have to consider when the quantity inside the absolute value is positive or negative. We're going to do the same thing here with these two absolute values. We're just going to choose one to start with. So I'm going to start with what's inside this absolute value could equal exactly what's in here. So that's the positive solution. Or when I, again, keep this the same, it could equal the negative solution, or the negative quantity inside. So everything inside that 3x plus 5 inside the absolute value could be negative as well. And it does not matter which one we start with, because if I had started with this absolute value, well, I could have said this equals exactly that, right? That would be the positive solution. Or this equals, I take that whole quantity multiplied by negative 1, which would just be this equation if I multiply both sides by negative 1. Right? This negative would become positive, and then this whole left-hand side would become negative. So it doesn't matter which equation you start with, it's just one stays exactly the same, and then I consider the positive solution, which means I leave it alone, and the negative solution, which means that whole quantity has to get a negative distributed through. So now I have my two equations that I can solve. So I start by, I'm going to subtract 3x from both sides to get all my x's on the left, and then if I do that, I can move my constant to the right by adding 5 to both sides here. Oops. And that's 0. 4x minus 3x would be 1x, or just x. 3x minus 3x is 0, and 5 plus 5 is 10. So there's one solution. Or over here, I'm going to distribute that negative, like a negative 1, through my right-hand side. So negative times 3x would be negative 3x. Negative times 5 would be negative 5. And again, solve. So I'm going to add 3x to both sides, and then add 5 to the right-hand side, making sure I have 0 for the constants, and then this actually also zeroes out. Negative 3 minus 3x would also be 0. And over here I have 4x plus 3x, which is 7x, equals 0. So it doesn't just disappear. The right-hand side of the equation is 0. I divide both sides by 7, and 0 divided by anything is still 0. So those are my two possible solutions. But I still need to check. It's so important to check because you could get what we call an extraneous solution, meaning it looks like a solution, I solved it, and it feels like a solution, but when I plug it back in, it just doesn't work. So let's check these. The first one, I'm replacing x with 10. And again, same thing, replacing x with 10. On the left-hand side, I have 40 minus 5, which would be 35. When I take the absolute value of 35, I'll get 35. Over here, I have 30 plus 5, again, is 35, which equals the absolute value of 35 is 35. So that works. If I plugged in 0, it's the same idea. 4 times 0 minus 5. Does that equal 3 times 0 plus 5? Taking the absolute value of those quantities. 4 times 0 is 0. 3 times 0 is 0. We'll be left with the absolute value of negative 5 equals the absolute value of positive 5, which is true, right? The absolute value of negative 5 is 5. the absolute value of positive 5 is 5. So that checks out as well. Alright, try the next example on your own. Alright, looking at this example, I have the absolute value of x plus 2 equaling the absolute value of 4 minus x. And we're asked to solve. So again, the goal is whatever's inside this absolute value that could equal exactly what's inside that absolute value. Notice I didn't change this to a plus. So when I say the positive, I don't mean change your negatives to positives. I mean leave it exactly as it is. This would be times a positive 1, which is itself. And then I could have that same quantity, x plus 2, could equal the negative of everything in there. So the negative of 4 minus x. And I have to solve these two equations. Over here I will add x to both and subtract 2. X plus x is 2x. That's 0. 4 minus 2 is 2. That's 0. Divide by 2. And x equals 1. On the right hand side here, I'm going to distribute through that negative. And I get negative 4 plus x. I'm going to subtract x from both. If I move my x's over here, I'm going to move my constant over there. This is 0, this is 0. So wait a minute, that's all 0. Negative 4 minus 2 is negative 6. But x minus x is 0. Well, that can't happen. 0 doesn't equal negative 6. So this one only has one possible solution, and we still need to check it. It's a good habit to check yourself by plugging in 1 for x, and same thing on the right, minus 1. Sometimes these absolute value bars can get changed into numbers, so make sure that you're identifying that they're absolute value bars and this doesn't become an 11 or a 14 or something like that. So inside the absolute value, I have 1 plus 2, which is 3, and 4 minus 1, which is 3. And in fact, the absolute value of 3 is 3. So that worked. Alright, I hope that helps. So always check yourself and look for extraneous solutions. And sometimes you'll get two solutions, like we did up here. We had positive 10 and 0 both worked. Here we had one solution, and sometimes you could have no solution. It is possible.